Great people, welcome to NameTech channel. My name is Nehemiah, and once again, I really appreciate you very much for coming on board. So this one is a full course on Scipy, and we are going to begin from the very basics to the advanced of Scipy. But guys, before I begin, please subscribe if you have not subscribed, and to the returning subscribers, I really appreciate you very much for your continuous support. Now guys, without further ado, let's begin understanding what is Scipy. Scipy is a scientific computation library that uses NumPy underneath. So it stands for Scientific Python, and it provides more utility function for optimization in statistics, stats, and also signal, processing. Just like NumPy, SciPy is an open source. You can use it freely. It's available. The code base is available on the GitHub. You can find it there. So why should we use SciPy instead of NumPy? So guys, basically if Scipy uses an NumPy underneath, so guys, why can't we just use NumPy instead? So basically Scipy has optimized and added functions that are frequently used in NumPy and data science. So basically guys, you need to know that this Scipy is a very important concept or an important part that you need to understand for those who are taking data science and machine learning, and of course other it is it can be incorporated in other many other stuffs, including web development and many others. So guys, basically which language is Scipy written in? So guys, as you can see, I'm teaching this Scipy and in Python. However, um, this one is predominantly written in Python, but a few segments are written in C, basically in C. And the code base, guys, I told you that it's available at the GitHub. So just go to this this URL. Just go to this website, github.com, and then github.com, then scipy, and then scipy, and then you are going to find the code base for scipy. But guys, you can check it out, but for now I want us to focus on the course, because I'm providing a full course tutorial on it. So, guys, what do we need before we begin? How do we get started here? So, guys, basically, because we are using NumPy, we are writing our SciPy codes inside the Python. We need to have Python in our system. How do we check if you have Python in our system? To check it, just go to your command line tool like a CMD, command, basically command prompt, that is CMD. You can use also PowerShell. You can use terminal on your Mac operating system, or Linux, or any other terminal that you have. And then guys, basically while you are there, just type in a Python, then a dash should be in small. I don't know if capital it work, but in most cases it's so guys, basically it should be in small. Just type in Python and then a dash version. Python is case sensitive, and then you can see now the version is 3.11.3. Alternatively, guys, if this one fails, you can just type in pi, then a dash version. And now guys, basically when you get the version, it will mean that you have Python in your system. So guys, in case you don't have the Python in your system, you might want to download it. Just navigate to the Python website. Just go to python.org, and then navigate to the download section, and then it's gonna prompt you with the download URL here. For me, it is a Windows operating system. That's why it has given me a Windows operating system. However, you can see it is supported on Mac and many other system, operating system. You can find the source code here. However, guys, basically for now, of course, guys, when you download and install, ensure that you click on all check boxes so that you may install all the required packages needed for Python, especially packages like a PIP is very important, because that's the tool that you can use to install other Python packages, including this Scipy. So once you have installed, and then basically once you have installed Python, you might want also to install this Scipy, because you must have Scipy in your system. So to install Scipy, just navigate once again to your terminal or your command line tool, and then type in pip. I said pip is a package manager that when you download Python, it usually comes with this. A pip is a package manager to install Python packages. So in that case, I'm gonna use it. Pip install Scipy. It is Scipy that we are installing. Scipy like this, and then let's give it time to install in our system. So it's gonna take some time. However, guys, basically I always recommend my colleagues or my students to use Anaconda. Anaconda is an environment is a very powerful place where you'll have every kind of the Python modules or Python packages which are useful for data science and machine learning. You'll not have to install it manually. And let me show you that, guys. To download the Anaconda, you're going to do what you're going to type in anaconda.com, then a products, then a distribution, then product. Actually, anaconda.com products / then a distribution. However, guys, you can just type anaconda, then just type in a download like this, and then when you hit enter, it will direct you to the download section, and then let's give it some time so that it may take us there. Let's so guys, basically you can realize that here this Anaconda is a free download. There's no a payment for it. It is you can see here everything you need to get started in data science on your workstation. Then you can see it's a free distribution install. Thousands of the most fundamental data science and artificial intelligence and machine learning packages will come with this Anaconda. And then you can manage packages and environments from desktop application. How awesome, guys! Also, you can see here you can deploy across hardware and software platforms. So this Anaconda is very awesome, because I not have to install packages external like what we are doing here for for this Scipy. So guys, I think as we wait for it to finish, as we wait for this to finish, guys, let me show you how you can download. So for me, I already have it on my system, but for you, just click on the download. It will download. Then to install, I think everything is just straightforward. Accept those agreements, and then hit next until you finish the installation. So once you have installed that Anaconda, you'll want to install to open or to launch the Anaconda.navigator, environment or platform or application. So when you launch it, you'll have this kind of an interface where we have several programs like a dataspell, cmd.exe, a Jupyter Lab, we have Notebook, we have PowerShell, PyCharm Community, Qt Console, Spider, and many others, guys. So for me, I'm gonna use Jupyter Notebook where we are going to write our course. But I guess you can as well use your preferred, a notebook like a Visual Studio Code. You can use PyCharm. You can use any other, guys. But if you want us to go along in this course, I recommend you to use what I'm using. Just use Jupyter Notebook, but I'm not limiting you to use your preferred notebook. However, just click on it, it will launch, and it will take you to your default browser. For me, it will take me to Chrome, because Chrome is my default browser, and I had already launched. And guys, you can see here I created this full course here. I created this basically, guys, I created this one is a txt. However, guys, I think it will navigate you, it will take you to a place where you'll have this kind of folders. So you're going to decide where you're going to place your project. Like you can decide to place it at the desktop. Remember, this one is linked to your system, file explore. Like for example, this is a Scipy full course, it is at the desktop. But when I navigate to my file explorer at the desktop, you can say I have that Scipy full course. So it is linked. What you're doing here, if you create a file here, it will also create on that end. So what I do here is to create the Python program, just click here the new, basically at the Python notebook, And then I click here to select your Python interpreter here. We are using Python 3. Just click on it, and then it will take you to this page where you have sales and some stuffs here at the top. I think guys, as you use it, you'll understand every aspect here. Like when you hover, you can see you have some details here. This one is to add new cells. This one is to cut cells. This one is to copy selected cells and so forth. However, in this juncture, guys, I want to focus on learning Scipy. So here, let me just change the title from title to let me say Scipy. Scipy for Scipy full course. Then let me rename. So it's Scipy full course. Let me try to close these other tabs so that I may not confuse you. Um, so um, so guys, now you want us to begin straight away. However, let's confirm if it has finished to install. To install this Scipy. Guys, you can see it has finished to install. But if you're using an account environment, it usually come with this, so you'll not have to install it. It usually come with everything, and then you'll have the environment where you're going to use it. So now guys, at this moment I want us to begin straight away. So before you use Scipy, you must import from your system. So once Scipy is installed, then you have to import Scipy module. So guys, basically once you have installed Scipy, and then we have to import the Scipy modules that you want to use it in your application. This one is not like an NumPy where you can just import it directly. This one you have to specify the modules that you want. So like for example, from Scipy you can decide to import constants, you can decide to import anything. Like this case, let me try with the constants. So use from keyword from Scipy import. We're going to import. Let's begin with the constants. So we have done what we have imported this constant from this module called Scipy. So guys, basically we have imported it. So how can we use it? So in this case, guys, when you have this line of code, then it means that your application is ready to use it. So for example, let's say, if you want to find how many cubic meters are in 1 liter, you can do this. Let's say print a constant, constants, constants. I think this is a spelling for constant dot liter. And dot liter, is this a spelling for liter or it's begin with an R here? Let me just run and see if it will work. Yeah, I guess you can see it is 0.001. Let me try to change the spelling here and see if it will work. Oh, guys, it gives you the same results if you are not. But I think this is the spelling for liters, for liter. But either way, it gives you the result. You can see 0.001 cubic meters. Cubic meters make 1 liter. So remember constants. Scipy offers basically a set of mathematical constants. One of them is this liter that you have just you returned here. So I'm gonna talk about these are constants as we go on. However, let me just show you how you can check the version of Scipy that you're using. First of all, you import the module. Like let's say import the module that we're using here is Scipy, and then here we can say print. And that guys, you can as well use it as an alias. However, let me just say scipy dot then underscore, two underscores, then a version, then underscores, two underscores. Then when you run, you get the version of a scipy that you're using. You can see it is 1.10.0. So basically you have to use these two underscores here for you to obtain the version. It is two underscores here. Now guys, basically let me now talk about the constants in detail. Here I've just showed you how you can use it, how you can use the constants, but we have several. I've just shown you how you can use liters as a constant, as a one of the unit, as one of the constant unit these are constant, a submodule of Scipy. However, we have several, constants, many ways that you can use. And so basically, as Scipy is most focused on scientific implementation, it provides many building scientific constants, and these constants can be helpful when you're working with the data science. Pi is an example for data science, constant, pi I think is 22/7, yeah. So I want us to obtain, for example, the pi value. So what I do, let me just, copy, then I paste it here on the new cell, and then I hear instead of liters, I'm going to use a pi. Pi is written pi like this. Then when you run, you'll get the value of pi, which is 3.141592653589793. So guys, basically, how do we obtain the constant units? Guys, basically a list of all units under the constant module can be seen using the dir, function. So like, for example, if you want to obtain all the constants available in this SciPy, you can just use these are function dir, and then these other constants should be inside the quotes like this, and then you close, of course. And then when you run, you'll find all the constants. You can see, guys, that there are very many. You can see there are very many, even others perhaps you have never heard of it. You can see there are very many. We have yeah, there are very many, quite many, guys. So, and basically the list continues. So guys, remember these units are placed under the several categories. We have the matrix, binary, we have the mass, angles, time, length, pressure, volume, speed, temperature, energy, power, force, and so forth. Like, let me begin perhaps with the matrix. Let me begin with the matrix. So, guys, basically, if you want to return the specified unit in meters, for example, you want to return centimeter to centimeters, for example, from meters to centimeters. Let me show you guys that what you do here. Let me just do I have to repeat? Let me repeat. So let me say from SciPy, import constants. Remember, constants is just one of the function or one of the submodule inside the SciPy, but we have several. But I want us to begin with these are constants as we go on. So, for example, if I want to obtain the iota, for example, we'll say print and then our constants like this. Then you specify, for example, if it's iota, a very smallest number, iota like this. Then when you run, you'll find the value of what? You'll find the value of, basically you find the value here of the iota. For example, if you want to obtain the deciliter, for example, you just say what? You just say deciliter. Remember, this conversion is from meters to the specified unit here. For example, remember that by default is in meters. However, when you want to convert it into other units, you can specify. For example, if it's kilo, it is, I think it's 1,000. Yeah, it's 1,000. For deciliter, it is deci. When you run, you'll get is 0.1. Then for example, if you want to obtain the micrometer, basically micro like this, I think, micro like this. Then you'll obtain the value micrometer, and then a decameter, you just say deca like this. I think deca is what? Deca is 10. Deca is the spelling for deca, or deca like this. I don't know. Let me run. Yeah, you can see it gives you the same results. So basically, this one is this one is for a metric. However, you have others like a binary, basically the prefix. Like, for example, if you want to return the specified unit in a bytes, you have you can convert, for example, from kilobytes. megabytes, gigabytes. Remember the standard unit here, it will be bytes. So what you do, let me just let me just use this one, right? So for bytes, for example, if you want to return kilobytes, you just say kbi. Remember kilobytes, the conversion is 10 24 1024. It should return 10 24. Yeah, I guess you can see it has returned 1024. This for kilobytes. Megabyte is me b. When you run it, it will give you what wa. Guys, basically should be megabytes, right? Not me b. It should be megabytes. Then when you run, it will give you the result for the megabytes. And then for gigabytes, you just say GB now. GB for gigabytes. And then for terabyte is TB. TB, it will give you the result for the terabyte, and the list continues. Now for mass, the SI unit, remember, is in kilograms. So for example, if you want to convert from grams to kilogram, you can just say, for example, gram like this. Then you'll obtain what? You'll obtain the grams. Basically, 0.001 grams make 1 kilogram. Remember, the SI unit here is kilogram. So every conversion, are focused on kilograms. So for example, if you want to convert from a pound, you just say pound. How many pounds make 1 kilogram? Then when you run, it will give you these values, and the list continues. We have the reference on the website. You can find everything there. The name tech website, just get there, and then you're gonna find everything there. I'll attach the link in the description so that you can find everything there. So for angle, the SI unit here, the specified unit is in radians. Now, for example, if I want to convert degree to radians, you'll do this. You just here say, for example, degree, how many degrees make 1 radian. When you run, you'll get the value to 0.0 whatever here. For for example, we have many others. Like if you want to get the basically the, for example, arc mini, you'll get the results there. So guys, basically these are for angles. Now for time, it is in seconds. For example, hours into seconds, it will be for hours, it will be hour. How many hours make 1 second? So it will be, things should be negative. Yeah, guys, basically it is basically this way. It is how many seconds make 1 hour? It is 3,600 seconds make 1 hour. For minutes, it's minute. How many seconds make 1 minute? It's 60. And then and so forth. For week, you can also try for week, year, month, so forth. You can see it gives. Now remember, for month you have to specify also the the type of the year, if it's the leap year, if it's Julian year, and so forth. So for length guys, it is the SI unit here is meters, meters, I think. So you can have the yards, mile, and so forth, the points. For example, if I want to get how many foot, how many meters make 1 foot, you can just say here foot, and then you'll obtain the results. For example, if you want to obtain the miles, how many meters make 1 mile, then you'll obtain the results here, and so forth. Now for pressure, it is the special unit is Pascal. The SI unit is Pascal. For example, if I want to obtain atmosphere to a Pascal, how many Pascal make 1 atmosphere? Just say atmosphere or ATM, they are the same. It will return what? It will return the value there. For example, if it's torr, you just specify torr, then you get the the value, and so forth. Remember the list continues. Let's try for area. For area, it is square meters. This is a unit here. Now, for example, if it's acre, you just say acre. I think this is spelling for acre. And then when you run, you'll obtain the results. If it's hectares, right? Uh, hectares, hectares like this, you'll obtain the result at the terminal. And so forth. For volume, you understand it is cubic meters. You can try, for example, liters, liter. Remember this liter and the other liter when when you have R here, it's just the same in NumPy. So these are basically we have also for speed, temperature, energy, and so forth. However, guys, I want us to focus on something else. I think you understand how to use the constants. By now, you'll find the reference on the website. However, let me talk about the optimizers in Scipy. So optimizers are a set of procedures defined in Scipy that either find the minimum value of a function or at the root of an equation. So this is essentially gives all of the algorithm in machine learning are nothing more than a complex equation that needs to be optimized with with the help of a given data. So let's begin with the root of an equation. Now, NumPy is capable of finding rows for polynomials and a linear equation, but it cannot, find the rows for nonlinear equation like, for example, x plus cos x and so forth. Now, guys, for that, guys, we have to use a Scipy. Scipy is that it has, added functions that can help you do some scientific Python computation much quicker. So, guys, for you to use it, you have to specify. You have to use the optimize.root function to achieve such like an equation like x plus cos x or a value plus the cos of that value. And then what you do, remember this function, the optimize.root function, takes two arguments, required arguments. The first one is a function representing an equation, and then x or x0 an initial guess for the root. I'm going to show you in a few guys, but remember that the function returns an object with the information regarding the solution, and then also the actually solution is given under the attribute x of the returned object. So guys, let me just show you that so that you may understand, you may relate to what I'm saying. So first of all, guys, I said you have to do it. Import the module. I say that a Scipy has many modules, so if you want to specify a specific module, you have to use the from keyword from Scipy, from scipy.optimize, from scipy.optimize, import root, and then also we are going to import here math. So let's say from math, import of course. Remember math you don't have to install it. Math is already available on your system. When you download Python, I think it usually come with the math functions, so you will not have to install it manually. And then here you can define your equation, your function, like let's say define it. This function is an equation, like let's say eqn for equation. Then let's give it x, and then now here, remember also when you define a function here, the end you must close, and then you specify. Let's return something. Let's say return for example x plus, for example, let's say cos. Let's say cos of what, of that x, and then here let's do it. Let's say let me create a variable here. For example, let me say my root of a function. Let's assign it to the root function, root intro eqn, this function here. Remember, once you have defined a function, you must always call it, and then first of all, then a 0, and then here the print function, we are going to say what should be 0, not O. And then here you have to do what you have to say print and then we are passing what? We're passing that variable my root dot x, my root, dot x. Now when you run, let's run, and then guys, you can see we have the results here. You must know that you need to note that the return object has much more information about this solution. So guys, basically, or rather guys, let me just show you how you can print all the information about the solution. If you don't specify the x here, you just specify the root, it will give you, to obtain you the all the explanation. You can see it gives you, the entire statements, the message solution converged, success, true, status, then we have these other stuffs, if you want to obtain that results. Now let me talk about minimizing a function. A function in this context represents a curve, and basically curves have high points and the low points. The high points are called maxima, and then the low points are called minima in this Scipy. And then at the highest point in the whole curve is called the global maxima, and the rest of them are called the local maxima. And then also the lowest point in a curve is called the global minima, whereas the rest of the area are called the minimum, the local minima. So how can we find the minima? Okay, so basically in that case we have to use the scipy.optimize.minimize function if you want to find the minima. So you have to use what scipy.optimize.minimize function to minimize the function. And then basically remember the minimize function takes the following arguments. First of all, it's fun. This one is a function representing an equation. Then x0, this one is the initial guess for the root. And then we also have the methods. The methods, these are the names of the method to use, like the legal values like CG, BFGS, and so forth. And then the other argument here is called callback. Basically, this one is a function called after each iteration of optimization. Then we also have the options, dictionary finding extra parameters. So guys, I think it's better for me just to show you so that we make it every concept here. So I want guys to find the to minimize, basically to minimize a function as a function of some values with a BFGS. So what I do is here I have to use this. Let me just copy this one. Let me just copy this one. But now guys, we are not using. I said that it has several functions. We are not using what we are not using a root here. We are using what minimize function. Then let's define our equation, our function. Let me use eqn for the equation. Then let me give it x. Then here guys, let's return perhaps x multiply 2 plus plus for example x, then for example plus plus 2, and then here let me create my minimum variable, my mean. You can use another variable, my mean, and then let me assign it to minimize what minimize we are minimizing this eqn, that equation, then 0, and then also we are using the method called what method, let's use method we are using BFGS. So it's the same, it is BFGS, should be in capital. And then what I do, let's print out, let's say print, then we are printing what we are printing that variable my mean. Then what I do, let me run and see the results. You can see, as you can see, it gives you the results with the entire explanation here, entire information. So guys, basically that's all about the minimize function. So guys, let me talk about the sparse data, and this one is very important. Of course, in data science and machine learning. So guys, remember sparse data is a data that has mostly unused elements, or elements that don't carry any information. It can be an array, it can be anything. So in a nutshell, a sparse data is a data where it's a data set where most of the item values are zero. And then a dense array is the opposite of the sparse array. So the dense array, most of the values are not zero. You know, a sparse data is a data that has what is a data set. Remember when I talk about data sets, it's just like a table. A table. So in your table, if you have many zeros, many zeros, I just know that you have a sparse data, and when you have many values which are not zero, then that one is an opposite. That one is a dense array. So guys, basically in scientific computing, when we are dealing with the partial derivatives in linear algebra, we'll come across sparse data. So guys, basically how do we work with this sparse data? So Scipy has a module called Scipy.sparse that provides function to deal with sparse data. So basically there are primarily two types of sparse matrices that we use, that is CSC, or compressed sparse column for efficient arithmetic and first column slicing. Then we also have the CRS, basically CSR. This one is a compressed sparse row for first row slicing and first matrix vector products. So in this course, guys, we'll be using the CSR, or a compressed sparse row. I want to show you an example here with the CSR matrix, how we can create CSR matrix by passing an array into the function. And of course, we are going to use scipy.sparse.csr underscore matrix function. So let me show you guys how we can create that CSR matrix from an array. What I do, we are importing what? NumPy. Remember I told you that Scipy is written underneath NumPy. So in most cases we'll be importing NumPy. So like here I can say import NumPy. Remember I installed NumPy in my system. If you don't have NumPy, you can just go to CMD and then I type in pip. We are using pip still to install these packages. Pip install NumPy. Pip install NumPy. Then I can install that NumPy for you. Remember for me, I already installed. That's why you can see the system already satisfied. So once you've installed, then I have to import it, just straightforward. So import NumPy, but I'm importing it as an alias, np alias, and then what else? Let's import. So let me say from scipy dot sparse. This is meant for sparse, right? And then import CSR underscore matrix and then let's create our array, or our NumPy array, because we are using NumPy array in this case, in this context. Let me just call it an array. Guys, I always tell you that it's a good practice to use descriptive variables instead of using X, Y, Z, B, A. It's a good practice to use descriptive names, especially if you're collaborating with other developers. They can relate that this variable was for this content. So it's a good practice to be descriptive when defining the variable. Of course, we have several ways you can create a variable. With the snake case, you can use also camel case. Then you have the Pascal case. There are three, I think there are three or four options on how you can define these variables. However, let me just use it this straightforward way. And then here, let me say, for example, np dot. Remember, np is an alias for numpy. Then here we're passing our array list, our one-dimensional array list that has sparse data. Sparse data, I see that it's a data that has most values are zero. Like let's have several zeros here. let me have zeros, and then perhaps 1, and then also 1, again 0, and then 2. So guys, basically you can see on this on this array list, you can see most of the values here are zeros. 1, 1, and 2. They are just three values that has and 0 values. So guys, basically let's do this. Let's try to create this CSR matrix from an array. Remember I told you that a CSR is a compressed sparse row. Is a compressed sparse row, and let's do that. Let's try to compress it. So in that case, guys, what I do, let me just say print print what print compressed sparse row matrix CSR, and then underscore matrix, and then we are passing what the array, we are targeting this array variable, array object. Then when I run, then guys, you can see it is now compressed. So guys, basically from this result we can see that there are 3 items with values. There are only 3 items with values here. We have the one here, guys. Basically this item is in the row number, it is in the row number 0, and then where at position 5, and it has the value of 1. I don't know if you are getting. Remember, indexing in NumPy or in Scipy begins from 0. 0 will tell you that this one is the first item in the row, or the first yeah, basically the first item in the row. 0 0 when you have 0, and then now this 5, basically this second 5 here is the position number, number 5, position number 5. This one is 0 1 2 3 4 5. The first one is at the position number 5. Then at the second one, it is at the 6. So it is at the row number 1, and then it's at the element or index number 6. Then at the value is 1. I think in case you understand now. For the third one, these two, it is at the column 0. I remember this one is just a one-dimensional array. It's at the column 1 actually. At this row 1, and then remember 0 is like 1. Just know that. And then at the position number 8, or index number 8, 0 1 2 3 4 5 6 7 8. It is at the 8, and then at the value itself is 2. That's how you can use compressed sparse row. So let me talk about the sparse matrix method. Now viewing stored data, for example, not 0 items with the data property. Let me just show you that again. Guys, basically what I do here, let me just use these same codes. Let me just use the same, or let me just copy, use it in a different set, then I'll try to modify a bit. So guys, here I want to have a 2-dimensional array here with some 1-dimensional array values. So a 2-dimensional array is an array that has 1-dimensional array as its element. So this one is this 2 angle brackets defines that this one is an array or a list, but inside this list we have 1-dimensional array. 1-dimensional array is defined using these quotes, and then you can have some values inside that array, like 0 0 0. So this one is a 2-dimensional array, but it has the first 1-dimensional array. You can have several 1-dimensional array, like let's add in another one, like again 0 0 1. So not comma, should be comma, right? 0 comma, and then 1, and then also let's have another, the last one. For example, let's say 1 comma 0, and then a 2, and then a 2 here. Then this in that case here we have to add in another property called data. If you want to do it, if you want to view stored data, if you want to view the stored data, it will not include 0. Let's try to run and check it out if it will work. And then I guess you can see it is 1 2 and 3. 1 not 3, it is 1, 1, 2. So it will exclude the zeros here, and then it will return only the stored data, and that's why you can do that. So how can we count the non-zero with the in this array? So guys, basically to count non-zero values, you have to use another property here called count. Count, count non-zeros, non-zero is a method, and then when you run, you'll find that the values are not zero, they are 3, 1, 2, 3. So guys, you can find that this concept here is very, very important, especially when trying to analyze data. So this concept is very, very important. And guys, basically, let me also talk about how we can remove zero entries from the matrix with the eliminate underscore zeros, method. And let me just show you that. Let me just this time use a new cell, but I'll have to copy paste these two lines of code because they're identical. They are the values that we are going to use here. And then now here, or perhaps guys, let me also copy these codes because I don't want to type the same things. There's a shortcut. And then here, guys, I want to do this. Let me create two variables here. Let me just call it the first one mat, and then matrix for matrix actually. Then let me say CRM, basically CSR. It is compressed sparse row, compressed sparse row, and then underscore matrix, Then we are passing what array. Remember, array is this array object is the object that the variable of the object of this object here. And then here again, let's create also the second one, which is eliminated. So let's say matrix dot. Then let's add in this other method here, not really a variable, it is a method, eliminate underscore zeros. Underscore zero is a method. And then what I do, and let's do this, let's say print, let's print the let's say print mat, and then again basically this one will do it, this one will remove zero entries from this matrix. Let me run and see if it will work. Eliminate. So guys, let's find out the error. Eliminate not found. So so guys, basically let's find where the error is. Where is our code? Oh guys, basically here I used a wrong keyword. I should have used zero, right? Zeros like this, and then this way it should work, So this is how you can do it. This is how you can eliminate those zeros. And then you can as well eliminate duplicate entries with the sum underscore duplicates method. So guys, basically in that case you have to change here to a different method. Let me just use sum underscore duplicates like this, and then when you run, you'll find out you'll eliminate the duplicates by adding them, So guys, that's how you can do that. And then also you can also convert from a compressed sparse arrow to a CSC. And remember guys, I told you that a CSC is a CSC is a compressed sparse column. We have compressed sparse row, and then also we have the compressed sparse, compressed sparse column. Let me just show you this one in a few guys. Compressed sparse column. So guys, basically in that case, from converting from a CSR from a compressed sparse row to a compressed sparse column, we have to use the two, and then you specify the method. Like for example, if it's compressed sparse column, you have to specify two, CSC, compressed sparse column. So this is our data, right? Let me just copy these two lines of code that I want us to convert from. That CSR, let's say it is a CSR, CSR. And then now, guys, I want us to convert into CSC, compressed sparse column. We'll just say new. Let me just call it new array. I'm using the snake case, and then let me say CSR underscore matrix and then here we are passing what the array then here you have to extend with this method dot to to compress sparse column now is a method. And then what you do here is let's now print the new array. Print the new array. New should be new underscore array. New underscore array. Then the result will be compressed. The new array is not defined, right? So, guys, basically here it should be array, right? It should be array. Then the results will be compressed sparse column, So, guys, basically apart from the mentioned sparse specific operations, sparse matrix supports all of the operations that normal matrices support, like reshaping, summing, arithmetic, broadcasting, like what we did in NumPy. However, guys, let me talk about something else in this Scipy, and let me talk about the graphs, the Scipy graphs. Now, guys, basically, graphs are very, very essential for data structure, and Scipy provides us with a module called scipy.sparse.cs graphs for working with such, data structure. So, let me talk about the adjacency matrix. Adjacency matrix is an nxn matrix where n is the number of the elements in a graph. So and remember the values represent the connection between the elements. Like I'm going to show you in a few. Like for example, guys, let me just show it so that I may explain the results for you to understand. So I want us to find all the connected components with the connected underscore component method from this Scipy. So guys, basically first of all, we import in NumPy, and then let me paste it here first of all. Then again here I'm gonna say what from Scipy dot sparse sparse dot cs graph, and then import connected underscore components, components like this. And then also we have to import that matrix. Let me just copy these ones, and let me just copy this one, and then let me paste it here again, because we must use what scipy.sparse. Then these are CSR matrix compressed compressed sparse sparse row. And then here let's create our array, and that's gonna be a two-dimensional array. Let me just use the same codes. Let me use the same codes, and then perhaps let me just try to split so that our values may be organized somehow. Let me just try to split. So this one is a two-dimensional array, and guys, I told you while we were discussing NumPy that a two-dimensional array is an array that has one-dimensional array as its element. You can see this one defines an array, or at least these are single and single. Basically the opening and closing of the squared brackets. However, inside these brackets, we have the other brackets. And remember, this one is a sample for one-dimensional array, and then we have several one-dimensional array. So these values are the components of this other array. That's what we call the two-dimensional array. And then now, guys, basically this new array, I want to do this. I want us guys to find all the connected components with the connected underscore components method here. So I'll create a new array. Perhaps let me just call it new underscore array. Then let me assign it to a compressed sparse row underscore matrix like this. Matrix should be matrix, and then passing what? A passing array. Then I hear the print function. Guys, what I'm gonna do here, let me just say let me say a print, then I'm passing connected underscore components, and then I'll create what? New array. I'll pass in new underscore array like this. And then what I do, guys, let's try to run. And then there's an error, right? Module not found. No module called spy. Guys, basically there's no module called sparse. Should be s. So I forgot. Should be s like this. So guys, basically you can see it gives you the results. You can see the connected components here. You can see. So guys, basically that's how you can find that. And then also, guys, we have something called Dijkstra. So okay, so we can use basically the Dijkstra method to find out the shortest path in a graph from one element to another. So it takes several arguments. The first argument is return underscore predecessors. This one is a boolean. Remember, boolean is a true, a false value. So a true will return the whole path of the traverse. Otherwise, it's false. Then another argument is synthesis. The indices is the index of the element to return all the paths from that element only. Then we also have the limit. Now this one is the max way of a path. Let me just show you again another example. So like let's try to find the shortest path from an element, for example, between 1 and some values like a 10, 12, or whichever values you have. So what I'll do, guys, let me just copy these codes. Let me copy these codes. Or guys, what I do, should I just copy everything? Let me just or let me just use these codes. However, I'll just modify here a bit. Instead of connected components, I'll use the Dijkstra. Let me just delete everything here, and then here I'm gonna use what? I'm gonna use remember it has a J somewhere, Dijkstra. Dijkstra like this, and then what I do here is here I want to change here from connected components to Dijkstra. It should be Dijkstra like this. I think it's okay. And then also here, guys, I should have done what I should have. And then also, guys, let me add in a new argument here. After there's a new array, I'm gonna add in another argument. I say that it takes that it takes 3 arguments. I said the first one is return. If you want to return a true or false value, remember true will return the whole path. We define that it will return the whole path of the traversal. If not, it will return a false. Also, I have to define that method. So I want it to return. What the predecessors. Should be predi. Say, is this the spelling for predecessors? I guess. When you give it a true, it will return what? I said that when you give it a true is a boolean. If you give it a true, it will return the whole path of the traversal. So like in this case, when I give it true, then let me give it index. I say that the index is what? Index, I said it is is the index of the elements of the to return all the paths from that basically from that element only. For example, if you specify 0, it will return element from 0. Remember 0 is like 1, so when you give it 0 and then guess let's try to run and guess everything is okay. Guess that there's an error, type error. Dijkstra got an expected keyword argument index, So should be indices, sorry. Should be indices, not indices. I think there's a spelling for indices. And then what I do, let me try to run again. And then I guess basically you can see it has given you the the results here. It has find the shortest path from basically from element one to 2, from element 1 to 2. So basically the shortest path. Also guys, we have others like the Bellman Ford. We also have the Floyd Warshall, and then I have the depth first order. You will find everything on the website. Basically, we also have the breadth first order, and there are many others. However, guys, let me go to something else. Remember, you will find everything the reference on the website. I'll provide. I have a full course, the write-ups on the website. So guys, let me now talk about the other thing here. I want us to talk about the Scipy spatial data. I've talked about the sparse data, I've talked about the graphs. Let me talk about this as spatial data. And guys, basically for spatial data refers to the data that is represented in a geometrical space, like for example, points on a coordinate system. So guys, basically we deal with spatial data, we deal with the spatial data problems on many tasks, like for example, it can be, for example, finding if a point is inside a boundary or not. So basically, in that case, Scipy will provide you with a module called Scipy.spatial, which has the function for working with the spatial data. Like, for example, let's begin with triangulation. So a triangulation is of a polygon is to divide the polygon into 3 multiple triangles with which we can compute an area of the polygon. Like triangulation with points means creating surface composed triangles in which all the given points are on at least one vertex of another three triangles of any other triangles in the surface. So one method to generate this triangulation is through the points. It's called the Duliny triangulation. Let me just show you guys so that at least you may relate. What I do, let me copy these codes because these are our reference codes. Let me just copy. Don't know why it's failing to select the codes. Let me paste it here and then try to modify a bit here. So instead of Dijkstra, let me change here to Duliny. Let me change here to basically to Duliny. Duliny like this. So what I do, the codes remain the way they are, guys. But then guys, because I will want us to visualize. So instead of this as sparse data, we are going to use Matplotlib. So let me say from, because I want us to visualize. So let me say from, let me say import matplotlib.pyplot but as a plt alias plt. So guys, basically then here perhaps let me just change here to the points. Let me call it points. Perhaps let me just use 2 elements inside it. For example, let me say 2 and 4. Also here, let me change to another point like 3, 4. And then here, let me change here to another coordinate like 3, 0, 3, 0, comma. Let me also create another one for perhaps 2, 2. Let me begin, let's say 2, 2, right? Let me say 2, 2. And then the last one, perhaps the last coordinate here, you can say, for example, 4, 4, 1. I should be inside the should be 4 1 like this. And then guys, let me do it. Um let me create now that variable for dealing a points for simplices. So what I do here, guys, let me just say simplices like this. Then let me assign it to dealing a function d. Dealing it like this. Then I'm passing the points that variable object for our object. Then I'm gonna pass in this method called simplices like this. Simplices. I think this is spelling. Now, guys, basically I want us to visualize, and of course, I want to trim or to slice some points. So, for example, it's gonna be I'm gonna use a try plot here. So let me say PLT. They allows for matplotlib. Then let's say dot try plot, and then it's gonna be from these are points. From these points, and then I'm gonna specify from the starts, basically from the starts to 0, and then also let me and then also let's add in the second argument. Remember, the second argument, let me use what? Let me say points. The second point is gonna be from what? From the start to perhaps 0 again, and then also let's close with these simplices. Simplices, and then also guys, I want to use a scatter plot here. So I say plt dot scatter, and then here I'm gonna pass in the points from what? From let me just copy these ones. Let me just copy. Let me copy. Then what I do? Let me just paste it here. Let me paste it there, and then here guys, let me specify the color. Color perhaps it can be. Which color should we use here? Let me just use red. I think red is dominant. Can be seen by everyone. Let me use red, and then to visualize here, we are not using the print function. We use the plt.show function, matplotlib.pyplot.show function. And then what I do, let me try to run. I think every code is okay, guys. Basically, there's a typo error. So guys, basically you can see here you cannot import the DNA from. Oh, guys, basically this one should be found in there. This one should be, I forgot to change. I just there's the issue with the copy pasting. This one should be spatial. It's not a good practice to do copy pasting because it can give you a lot of issues. So what I do, let me try to run again and see if it will work again. Let's find another error. Points. Points is not defined, so I forgot. Should be points should be I here, and then let me run again and see if it will work. Yeah, guys, basically you can see it does. Oh, guys, basically it should be triangulation. I forgot here, guys. I should have used 1. Let me use here 1, and then also here let me change here to 1. Let me change here to 1 so that it can give us a good triangulation. Let me run again and see. So guys, basically this is what I wanted. You can see it has given us these are triangulation. So this is how you can do it. This is how you can create a triangulation from these are points here. So guys, basically you should note that this simplicity property creates a generalization of the triangle notation. This simplicity that we used here. And so basically you should know that. So guys, let me talk about the convex hull. Now a convex hull is the smallest polygon that covers all the given points. Now we use the convex hull method to create a convex hull. So let me just let me just use these codes, guys. Let me just use these codes. So for example, here instead of, let me just extend the codes here, or let me just use a new set so that uh, you can understand everything here. Let me try to zoom in a bit. So here we're going to change here from delineate to convex hull. Convex hull. A convex hull. Then again, perhaps here let's extend our points. Perhaps here let me use perhaps 1, 2, comma. Then the other one let me use 50, perhaps 50. And then the other one perhaps let me use a 3. Let me use a 3, 1, perhaps 3, 1. Then the other one let me use 1, 2, 1, 2. And then the other one let me use what? The other one let me use perhaps 0, 2. Let me use something like a 0. And then a 2, 0, 2. And then what I do is think they are okay. Let me now change here from delineate to convex hull. You must use the exact method. Let me just paste it here, convex hull. And then so guys, basically here I should have changed here to let me add in another variable. Let me use instead of simplices, let me use a hull. Should be hull. And then here guys, let me also create another one for, let me just delete these simplices because discussing simplices. And then here guys, let me do this. Let me just use let me say hull, the second variable hull points. Let me assign it to hull.simplices hull.simplices like this. And then guys, should I modify these points here? I want to use a for loop. So guys, basically here let me just delete the second part here. Then I'll use let me just delete this part. Then let me use a for loop. Let me just say for I should have closed, right? Let me just close. And then here guys, I want to use a for loop. So let me say for basically simplex. So let me say simplex or any other name. Simplex in hull underscore points. Underscore points. And then what I do here, let me just say plt dot plot. And then here I'm passing what? I'm passing plt.plot. Then here I'm passing points, and then simplex. Let me pass simplex, and then 0. Again here let me also add in another thing called points, the second point. Then here let me say passing simplex. Simplex, and then 0 again. Let me give it not 0. Let me this time give it 1. And then also guys, let me add in another last argument here, k negative, negative 1. And then guys, let's try to visualize and see if it will work. Of course this line of code I should have deleted it. Then what I do, let me try to run and see if it will work. So guys, basically simplex is not defined. Sure, is not defined, so it should be simplex like this. Then when you run, it should give you the results. So guys, basically you can see it gives you the results. Let me try to zoom out a bit. So guys, basically this is all about the convex hull. Let me talk about the KD tree. Now guys, basically KD tree are data structures optimized for the nearest neighbors. Like for example, in a set of points, using the KD tree, we can efficiently ask which points are nearest to a certain given point. So the KD tree method returns the KD tree object, and the query method returns the distance to the nearest neighbor and the location of the neighbors. Now let me show you guys that example. Let me just say Scipy. Let me just, I don't know if you can see. Or rather, guys, let me just copy this first line of code let me copy this code. Then perhaps let me try to zoom in so that you can see what I'm doing here at this cell. But now here I'm gonna use now the KD tree, not convex hull. Let me use a KD tree, KD, KD a tree like this. And then here let me get my points, and then let me assign it to this list. Then I'm using a tuple here. Sorry, let me say what. Let me, for example, the coordinate. The first, let me use a 1, then a negative, perhaps a 1. The second coordinate, I can give it 2 and what 2 and 3 perhaps. And then the third coordinate, I can give it perhaps negative 2, then 3. And then the other coordinate, I can give it what, let me give it 2, then negative negative 3, like this. So guys, I don't know where this other quotation came from. Yeah, I think this way is okay, right? Then here, let me create a variable for the KD tree. Let me say KD tree. Then let me assign it to the KD tree. Then let me pass in what points. Points. Then let's find the. Let me create this variable. Then let me assign to KD tree to find that. Okay, so basically in this context, we are trying to find the nearest neighbor. Like for 2 point perhaps, let me use a 1 to 1. So in this case, guys, here I'll pass in what dot query. I say that this query method returns the distance to the nearest neighbor and the location of the neighbors. So I'm gonna use the query, and then the coordinate that I want here to find is this coordinate 1 and 1. Basically, this coordinate 1 and 1. Let me pass in that variable. Let me pass in this object. Let me say print. And then I'm passing what, let me pass in rs, then let me run, and then guys, basically kd3 is not defined. kd kd3 dot query is not defined. So guys, basically what you let me try to change here to capital. I don't know if it will work. kd3, then let me run. And then again, basically you can see the coordinates here is 2.0, then the 0. So okay, so basically that's how you can do that. Now let me talk about the distance matrix, and we shall begin with the Euclidean distance. Now let me talk about this distance matrix in a few before I dive into other stuffs. So guys, basically for distance matrix, there are very many distance metrics used to find various types of distance between 2 points in data science, Euclidean distance, cosine distance, and so forth. So basically the distance between two vectors may not only be the length of the straight line of them, between them, it can also be the angle between them from origin, or the number of unit steps required from
So basically, many of the machine learning algorithms performance depends greatly on the distance metrics like the k nearest neighbors or a k means. So for example, guys, let us look at some of the distance metrics, and I'm going to talk about the Euclidean distance. I will also talk about the city block distance, or sometimes called Manhattan distance, and then I'll talk about the cosine distance, some of the distance that are metrics that I want us to discuss in a bit. So let's begin with what? Let's begin with the Euclidean distance. So here is basically in this new cell, let me say from scipy dot spatial dot spatial, and then a dot distance import. Let's begin with the Euclidean or a Euclidean, right? I think the spelling is Euclidean like this, Euclidean or Euclidean. And then here let's find our points. So point 1, or let me just use P1. Let me use P1. And that is a good practice to use descriptive names. Then let me just say passing this coordinate 0, 1, 0. Then point 2, I can say P2. Let me pass in what these are coordinates 10, 2, and then let's say arrays. Then let me pass in what? Let me pass in the Euclidean or Euclidean. Then let's pass in point P1 and also P2, and then let's print out what we are printing. Let's say print, and then we are printing what? Guys, let's print that res. Then let's run. And then I guess you find the results here is 9.2 whatever here. So guys, basically that's how you can do it. That's how you can find the Euclidean distance between a given point. Now there's another type of distance here called the city block distance, sometimes called the Manhattan distance. Now this one is the distance computed using 4 degrees of movement. Like we can only move up, down, right, or left, not diagonally. So basically in that case, we have to change the module here to what? To city block. Now this defines either east, west, south, north, or up, down, left. Up, down, right, or left. And then here, guys, let me once I've used it here, you have to use it here. We have to change from Euclidean to city block. Then when you run, you'll find the value here. It is 11. We also have the cosine. Now guys, basically for cosine is a value of cosine of cosine angle between the points, perhaps point A and B. So in that case, guys, you just change here to cosine. Cosine. Let me copy and then also let me paste it here. Let me paste it here, and then guys, what I do, let me run. And then guys, you'll find the results here. We also have guys the human perhaps. Let's try to finish with the Hamming distance. So guys, basically this Hamming distance is the proportion of bits where two bits are different. Like it's a way to measure the distance for binary sequences. So like let me try to show you how you can find the human distance between a given point. Like for example, first of all, here you have to change here to Hamming. Let me also copy Control plus C, and then here guys, I'm gonna do this. Now this one takes the Boolean values, can be true, false, true, and then here let's do it. Let's say for example false, true, and then perhaps true again. Let's try to run. and then I guess you'll find the results here. So guys, basically there are many others, however, let's just have that at this juncture. So guys, let's talk about something else here, very important. It is called the Matlab Arrays. So guys, basically working with basically you know that NumPy provides us with the methods to persist the data in a readable format for Python, but Scipy provides us with the interoperability with the Matlab as well. So like Scipy provides us with a module called scipy.io, which has the function for working with the Matlab arrays. So perhaps I can talk about exporting that in Matlab format. So basically the save mat function allows us to export data in Matlab format, and the method takes some arguments like the first argument is file name. That's the file name of for saving the data, and then we also have the mdit. This one is a dictionary containing the data, and then a do underscore compression is a boolean value that specifies whether to compress the results or not. Now default is false. Guys, perhaps let me show you that. Let me say first of all we import that module. So from Scipy import IO, and then also let's import import NumPy, because I'm gonna use here NumPy array NumPy, then is a np alias, then here let's create our NumPy array, and then let me assign it to np dot arrange. Let me use arrange, and then here a range of 10, right? Then here at the print function, not really at the print, here I should have done it. Let me say io dot save mat, and then here I'm gonna pass not that array, should be array dot mat, and then also let's pass not of course vec, and then let me use a double quotes, right? Let me use a double quotes. The name now, and then should be what? Also, let's pass in that array. So, guys, basically in this example, the file name will be array.mat on our computer. So, guys, basically to open the file, we have to do what we have to import data from Matlab format. Let me first of all let's do this. Let's try to run, and then I guess it will basically not print anything, but I guess basically if you want to open the file, you check out the import data from Matlab format. For example, let me just show you how you can do that. Now guys, basically let me show you how you can import now that data from Matlab. Remember these codes, we have just created that file. So now guys, basically to the load mat function allow us to import data from the Matlab file. So basically the function takes one required parameter, that is the file name. The file name is the name of the file saved in the data. Like in this case, it will be what? It will be, you know, it will be array.mat. And then guys, basically what I do here. So remember guys, it will return a structured array whose keys are the variables names and the corresponding values are the variable values. So guys, for example, let me just show you another example. Let me just copy, or rather let me extend this stuff. Let me try to modify a bit. Let me use a one-dimensional array here, perhaps 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 9, and then I here guys, basically this one is to export, right? This one is to export, and then now guys, basically to import Remember this name already exists, so I don't know if it will work. However, let me try to, now to import gaze, you just say my data. You can give it any variable, my data, but for me I'm using my data, and then IO. Then here guys, I'm using the load mat guys are basically to load that file. Then here we are passing out array mat. It was array mat, right? Array dot mat is a string, right? Should be a string. A string also here, and then at the print function, let's say print. We are printing my data. Printing my data, and then what I do, let me run. Then guys are basically unsupported operands, types list and the integers. So guys, basically in this case I should have used the numpy array. This one is what is I should have changed here to array. Let me change here to array, and then let me try again to run and see if it will work. Then module scipy that has no attribute called load, or should be load mat. I don't know why I forgot to finish. Should be load. Then let me run and find another error. And then I guess basically you can see we have done that. We have imported this Matlab data here. So we can as well guys use the variable name. Perhaps we use here vec, the variable name vec, to display only the array from the Matlab data. Like if you want to do that case, I have to specify another. You have to specify that variable vec. Like guys, basically you can see. Remember, I just used vec. You can use another name, but I can see it returns only the to the array from the Matlab, data. So guys, basically we can see that the array originally was one-dimensional array, but here the extraction, it has increased to one-dimensional array. So in order guys, basically to resolve this, we can pass an additional argument like squeeze underscore me to true. So you have to add in another argument here, squeeze. So if you want to return the original data, squeeze underscore me, and then we assign it to a true value. Then when you run, it will give you your original data, of which is a one-dimensional array. And then guys, there's an error here. Got an expected keyword squeeze. The guys, basically this is not a spelling for squeeze. Should be double E, right? Squeeze. And then that way it will return your correct values. So guys, basically this is all about the Matlab with Scipy. Let me talk about the interpolation. Now first of all, what is interpolation? Interpolation is a method for generating points between given points. For example, for point 1 and 2, we may interpolate and find the points like 1.33 or perhaps 1.66. Now, interpolation has many usages. Like in machine learning, we often deal with missing data, and in our data sets, interpolation is often used to substitute those values. So basically, this is a method of filling values called imputation. Apart from imputation, interpolation is often used to where we need to smooth the discrete points in our data sets. So guys, basically how can we implement this in Scipy? So basically, Scipy provides us with a module called scipy.interpolate, which has many functions to deal with the interpolation. Like let's begin with the one-dimensional interpolation. Now the function interpolate in the P1D is used to interpolate a distribution with one variable, and it takes x and y points and returns a callable function that can be called with basically with the new x and return a corresponding y. So let me just show you that guys. And there's a new cell. Let me use, first of all, let me say from from Scipy dot in the interpolate, should be interpolate from Scipy dot interpolate import in the basically in the one, should be in the 1D, in the one dimension, in the 1D, if it's one dimension, in the 1D, in the 1D. Then guys, also we might want to, because I want to use the numpy arrange, so I'll import the numpy. So import a numpy is a np alias np. Then let's create a variable, perhaps let me call it x s. Then let me assign it to np dot arrange of what, 10. And then also let me let's say for y's, xy's, basically actually x-axis. So here I'm gonna give it perhaps 2 multiply by x s, this variable here xs, and then a plus perhaps 1, an increment of 1. Let me give it 1 even. And then here I'll say what, in the p, in the p, basically in the p underscore function. Let me assign it to this in the p one dimension 1D, in the p 1D. Then I'm passing the x and the y's, So let's create a new array now for new data. So it will be new. Let me just call it new. I don't want to write a lot, but it's a good practice to use descriptive stuffs. However, let me pass note. Let me use this one. Let me pass it here. And then again here I'm gonna dot. Let me pass in. Let me pass in what should be. Let me pass in np dot arrange, should be arranged. It should be arranged. Then I'm gonna give it these values, perhaps 2.0, comma, then 3, then perhaps 0.1. Then we are printing out the new object. So let's say print. Then we are passing that variable new. I don't know what you call it on your end. However, we got an error. Cannot import the should be in the p. Where is it? In the p. It should be in the p, right? Which line is it? Interpolate. Where is it? Oh, these are these lines. I should be in the p. Should be in the p here. In the p. I forgot in the p. For interpolation, in the p, then a 1D. Now when we run, we'll get the values here. We'll get the results. But you need to know that those new x should be in the same range as the old x, meaning that we can't call in the p function, in the p underscore function, with the values higher than 10, and or less than 0. So that's how you need to use that. Of course, guys, we have another one for spline interpolation. Basically, in one-dimensional interpolation, the points are fitted for a single curve, whereas in this spline interpolation, the points are fitted against the piecewise function, defining the polynomial. Basically, polynomials called splines. Now, basically the univariate spline function takes x and the y's and produce a callable function that can be called with a new x. The piecewise function is a function that has different definition for different basically ranges. Like, guys, should I show you that? Let me just do that. So here I should have changed here to univariate spline. Sorry, it should be univariate. It should be but univariate spline. It should be univariate, spline. I think this is spelling. Let me copy. And then here guys, I'll have to change here to this new, basically to this a function from interp and then I'll change here to univariate function. And then I'll pass in the x and the other values remain the way they are. And then guys, basically let me try to run and see the results. You'll get these values. So guys, basically here you can see this is how you can find the univariate spline for interpolation of 2.1, 2.2, all the way to 2.9, because it can't surpass 10. It can't surpass 10, right? And then we also have the interpolation with the radial basis function. Now, radial basis function is a function that is defined corresponding to a fixed reference point. Like the RBF function also takes x and y's and argument as arguments and produces a callable function that can be called with a new x and y's. Like, let me show you guys another example here. For example, if you want to interpolate the x and y's using the RBF and find the values. For example, between basically 2.1 all the way to another values. So so guys, basically in that case, guys, I have to modify here a bit. Let me just modify my codes here. This one is for basis function. Let me just change here to perhaps some other values, like for y's. For y's, I'll change here to x, 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 and then I'll multiply 2 plus perhaps np dot should be x, np not really, let me use a sign, and then let me pass in x, and then perhaps plus some other values like let's say 1, and then of course guys, here should be rbf. Let me copy, and then again let me use it here instead of univariate spline. Let me use rbf. Then what I do guys, let me just try to run and see the result. Guys, basically there's an error, right? Cannot import the name rbs from Scipy interpolate. So sure guys, basically it should be rbf. Sorry, it should be rbf, and then here also I should have changed it to rbf. And then when you run, you'll find the results here. So guys, basically that's how you can do it. That's how you can do interpolation. So guys, lastly, let's talk about the Scipy statistical significance test. And first of all, what is statistical significance test? Now, in statistics, statistical significance means that the results that was produced has a reason behind it. It was not just produced randomly or by chance. So Scipy provides us with a module called scipy.stats, which has the function for performing statistical significance tests. Like we have some techniques and keywords that are important when performing such tests. Like we have the hypothesis in statistics. Now the term hypothesis on your head, I think you can just relate that hypothesis is something which is an assumption. But now this one is an assumption about a parameter in a population. We have several hypotheses. We have the null hypothesis. This one assumes that the observation is not statistically significant. We also have the alternate hypothesis. Now this one assumes that the observation are due to some reason. This one is a alternate to hypothesis. Like for example, for an assessment of a student, we will take perhaps a student is worse than average, basically as null hypothesis, and perhaps a student is better than average. Now this one is an alternate hypothesis. So we also have another one called one-tailed test. When our hypothesis is testing for one side of the value only, it is called one-tailed test. Like for example, for the null hypothesis, guys, basically the mean, for example, it will be the mean, perhaps the mean is equal to k. We can have an alternate hypothesis, like it will be the mean is less than k, or the mean is greater than k, And then now we also have the two-tailed test. Now when our hypothesis is testing for both sides of the value, it will be, for example, let me show you that, let me just tell you an example for the null hypothesis. First of all, it will be the mean is equal perhaps to k. We can have an alternate hypothesis. It will be the mean is not equal to k. That's an alternate hypothesis, the two-tailed. So in this case, the mean is less than or are greater than k. Then the both sides can be, are to be checked. So, and then we also have the alpha value. Another parameter here is the alpha value. Basically, alpha value is the level of significance. Like how close to extremes the data must be for null hypothesis to be rejected. Like it is usually taken to as perhaps 0.01 or sometimes 0.05 or 0.1. And then now we also have the p-value. Now the p-value tells us how close to the extreme the data actually is. P-value and alpha values are compared to establish the statistical significance. Now, if p values are less than or equal to alpha, we reject the null hypothesis and say that the data is statistically significant. Otherwise, we accept the hypothesis. And then we also have another one called the t-test. Now, the t-tests are used to determine if there is significant difference between means of two variables, and let us know if they belong to the same distribution. It is a two-tailed test also. The function t-test, I and d, basically function takes two samples of the same size and produces a tuple of the t statistics. So guys, I think the best way is for me just to show you an example other than talking a lot. I think you understand when I talk. Let me just show you. So like, let's try to find if a value, perhaps value 1 and value 2 are from the same distribution. So guys, basically in that case, we'll have to import, first of all, let's import numpy. Import numpy is what? Is npls. And then also let's say from Scipy, from scipy.stats, from stats import t-test underscore ind, and then for value 1, let's create value 1, let's assign it to np. Let's use a random value here. Let's say random dot normal, random dot should be normal, right? Normal dot normal, and then at the range or at the size should be a maximum of, let me give it 100, and then and let me also create another random. I'll change here to v2, and change here to v2, and then here let's say res, then let's assign it to t-test underscore ind method, and then I'm passing v1 and v2, and then what I do, let's say print, and that results here. Though, so what I do, let me just try to run it, and we check the results. So guys, basically you can see it has given us the results here. We have find the if these are values are from the same distribution. You can see the results here. Statistics, we have the values, and then we also have the p-value. So there's so for example, if you want to return only the p-value, we use the p-value property. You specify the p-value property sorry. Then here just say p. If you want to obtain just the p-value, just say p-value. Then when you run, you'll obtain only the p-value, and then again you can see it will give you that results. Then again, let me talk about the KS test. The KS test is used to check if given values follow a distribution. Now, basically, this function takes the value to be tested and the CDF as two parameters. A CDF can be either a string or a callable function that returns the probability. So it can be used as one-tailed or a two-tailed test. So by default is a two-tailed test, but we can pass basically alternative as a string of one of the two side or a less or a greater. So so guys, basically in this case I'll have to do what I have to change here to another function here. I'll use a KS test, right? KS test, and then whereas here I should have changed it to KS test. KS test, and then here I'll pass in what? Let me just create this value. Then here guys, let me just here it should be just v. This one should be just v. Then also let me also create for norm. Then what I do, let me just try to run, and then guys, basically, of course, I should have removed the p-value so that it may return both, including the statistics. So let me run, and then guys, basically you can see it gives you, the statistics, p-value, statistical location, and many other stuffs here. So, and then guys, we also have the statistical description of data. And guys, basically in order to see summary of values in an array, we can use the describe function. And then this one will return the following description. Now, the first one is the number of observation. The second one can be perhaps the minimum and the maximum value, or min max. Sometimes it will return the mean, variance, skewness, and also kurtosis. So guys, basically in that case, you'll have to do what you have to import describe like this, and then here you change also to describe, then here you just pass in what v. Let me remove this and this one, then let me return. So guys, basically when I run, it will return the first item will be the number of the observation, or an ops. Norms will be the number of observation. Then at the minimum and the maximum, it will be min max. Then a mean, variance, skewness, and a kurtosis. Let me run and see. You can see number of observation is knobs. Min max, that's minimum and the maximum values. And then mean, you can see this value, variance, it is this skewness, and so forth. So basically, let me just try to explain to you what is perhaps skewness or kurtosis and other stuff. So let me try to define for you so that you can relate, so that you can understand what is skewness and kurtosis. Now, normality tests are based on the skewness and kurtosis, and the normal test function returns the p-value of the null hypothesis. Now, like x comes from a normal distribution. And then a kurtosis is a measure of symmetry in a data. Like for normal distribution, it is 0. So if it's negative, it means that the data is skewed next. If it's positive, it means that the data is skewed right. And then the kurtosis, this one is a measure of whether the data is heavy or lightly tailed to do a normal distribution. Positive kurtosis means it is heavy tailed. Negative kurtosis means lightly tailed. So, like, let me show you that example, guys, for you to understand. Now, in that case, guys, let me just import both skew and what kurtosis like this. And then here the print function, guys, I'll print the skew. Let me remove this one. Let me say print. Let me print first of all skew. Should be skew of V, and then again I want to print also the kurtosis of what? That V. Now guys, basically let me repeat again before I run. I say that a skewness, this one is a measure of symmetry in data, like a for normal distribution it will be 0. So if the result is negative, it means that the data is skewed to the left. If it is positive, it means that the data is skewed to the right. Now for kurtosis, it's a measure of whether the data is heavy or lightly tailed to a normal distribution. If it's positive kurtosis, basically if it's heavy tailed, it will be a positive kurtosis. Basically, if you get the results which are positive, it means that it is heavy tailed. And then if it's negative kurtosis, it will mean that it is lightly tailed. Let me run and try to. You can see guys, both skew and the kurtosis are negative. Now for skew, this one will mean that the data is skewed to the left. Then this one it will mean that the kurtosis is lightly tailed. That's why you can see the result is negative. So guys, basically this is the end of the course, and I really appreciate you very much for your time. And I guess by now you are going to be a professional data scientist or a machine learning engineer by understanding this concept of Scipy. And guys, I recommend that you share this video to your friends so that they too may also learn something new. But all in all, I really appreciate you. Please subscribe before you go, and also like the video. I really appreciate you very much. And until next time, thank you very much.